Hi, welcome to N67. This is improper and mixed fractions. So we know that fractions are numbers that show part of a whole, just like decimals, right? But in this case, we have some whole items as well as a fraction. So this is what improper and mixed are going to show, is whole numbers plus fractions, okay? And we are going to do this with pictures like this one that I just drew. And you can use manipulatives like blocks and measuring cups and things like that. You can list and draw equivalent fractions. This should be something that you already have under your belt from grade 5. If you're not good at equivalent fractions, go back to that grade 5 video and have a look at that one. Finding examples of fractions, including improper and mixed, and explaining the meaning. So I've got a few examples coming up for you. How they are exactly the same, it's just two different ways to show that same number, and to be able to change them. So this is sort of where the math comes in, is being able to work with those numbers. Using representations to change, so mixed to improper, and then improper to mixed. They go both ways. Putting them on a number line, where exactly do they fit and how much are they showing? And let's answer this question. Can quantities less than 1 be represented by a mixed number or improper fraction? Well, if you were listening to this first part, I already said that the whole point of improper and mixed is to show numbers that are greater than 1, because we have, one whole, and then we have a little fraction to go with it. Maybe like that, right? Okay, let's have a look. So here is the definition for each one of these guys, and you'll need to know this, improper and mixed. So improper is where the top number, your numerator, is much bigger than the bottom, the denominator. So usually in a normal fraction, like 1/3, the bottom is the bigger number, and it shows that we had a shape that was divided into 3, and one of them is shaded. Okay, we all know what 1/3 should look like. So what do we do when we have something that's cut into tenths? We'll see how my drawing is here. Not bad. Okay, give me a raise. Okay, so we have my shape. It's cut into tenths, but it says that 25 of them are shaded. Well, how does that work? I can only shade 10, right? There, I've shaded 10, 10 out of 10. Okay, but I have 25 of them to shade. So that must mean I need to make another one. Did I do that right? I think so. And shade those in as well. Okay, so I have another 10 out of 10. So all together, so far, I have 20 out of 10. I have 20 tenths all shaded up, and now I need 5 more. So one, two, three, four, 5. Okay, so there's my 20 tenths plus my 5 tenths, and that equals 25 tenths. So using an improper fraction is a way to show that we had more than one whole number. Now these are handy to work with. It says we use improper fractions in equations because they're easier to work with. If you're going to add, subtract, multiply, or divide a fraction, you want it to be in this improper form because it's much easier to work with. If it's in the mixed form, like that, it's just too tough to put into an equation. However, the fraction police will come along at some point and they want your answer in lowest terms. This is how you show lowest terms, putting it back into the mixed form. So over here, my funny fraction cartoon says, "I will not let you leave this house looking so improper, young lady." So she has the bigger number on the top, meaning that she's being improper. So it's like the equivalent of short shorts, just in fraction land. Alrighty, so when we're converting fractions back and forth, we need to use long division. And I like to use that symbol for long division. And a few years ago we were using this in the classroom and I wondered what the symbol was called. Well, apparently it doesn't even have a name. So sad. And so we thought it sort of looked like a cave, like maybe bears could live in here. Yeah. And so inside here is the cave. Now it looks like a lion with bear ears. Gosh, I'm a good drawer. And since this was a cave that was used for division, we called it the Cave of Division, and then it just made sense to call it Dave. And so you'll hear me refer to a Dave every once in a while, and what I mean is this symbol right here. We're going to use division for this. And this will be a good test to see if you actually watched the video or not, because there is nowhere in the world that you're going to find the definition of a Dave except for right here, because we totally made it up. Okay, so here you can see the Dave is in use. Converting a mixed fraction into an improper fraction. And so, converting to a mixed fraction. This is known as reducing. So this is where the fraction police come along and they say, whoa, whoa, 25 over 10, that's not lowest terms. You need to put it into lowest terms. And so we're going to use a Dave. He's probably really glad he has a name. When you're using a Dave, you might wonder, where do I put the numbers? Which one goes on the top and which one goes on the bottom? Well, remember, your bottom sticks out. Your butt is so big. No, my butt's bigger. Okay, so your bottom of your fraction let me get the right colors here. The 10 is what sticks out of the cave. Okay, so it's on the outside of the cave. Good to go. So we set up our fraction, we take our 25 over 10 and we put it into a Dave. The bottom sticks out, so the 10 is sticking out and the 25 is inside the cave. And now we think, well, does 10 fit into 2? No, so I'm going to put a 0 there. Does 10 fit into 25? Yeah, it goes twice, so I'll put a 2 up there, and there's 5 left over. Okay, as soon as you get your remainder, you're finished. And now you need to decide where to put these guys. So what we found is that 10 fit into 25 2 whole times, right? And so we make the big 2. It went in 2 whole times. And then we said there were 5 left over, and so 5 is the top of your fraction. That's your numerator. And it didn't show very well because I did it on the computer. When you type fractions into a computer, it likes to write the fraction bar on a slant like that. I don't like that. I would prefer that people write it straight up and down. So what we had, or straight horizontal. What we had there was 2 whole times, 5 left over, and this is a good rule to remember. Keep the original denominator, which was 10 from the original guy over there. So 2 and 5/10. Now, fraction police are still not happy. We need to reduce this because we know that 5/10 can be reduced down to 1/2, right? Because 2 and 5/10. If we divide both the top and the bottom, what you do to the top, you must do to the bottom. I'm going to divide by 5. That's where we get our 1 and our 2. So our final answer is 2.5, and we are done. Now, going the other way, converting to an improper fraction. If you are given this guy and told to maybe multiply or add or subtract with it, that's going to be very difficult. So what you want to do first is convert it into an improper fraction. So to do that, think of the little loop and swirl here. We're going to take that whole number, we're going to loop down here and multiply by this guy, and then we add the top. Okay, so let's do that again. Loop and swirl. Go down to the bottom, multiply by 3, which is 3, add the top, which is 5. So 1 times 3 equals 3, add the top, which is 5, and then, same rule as before, original denominator, which in this case was 3, right? And so there is our improper fraction, and improper fractions are pretty handy for multiplying and dividing and things like that, right? Okay, so just a quick review. This is a proper fraction, 3/5. That's normally what we would see. Fraction police would like that. This is an improper fraction. Its dad is not going to let it leave the house, but it's very handy for doing operations with. Okay. And then we have the mixed fraction, and the fraction police like that because that's in lowest terms. And no, Mr. Ape, we didn't say anything about your bottom, honest. All right, so here is the picture is obviously a representation. You can show it with a improper fraction and then convert into a mixed. So let's do a little converting here. Let's do the loop and swirl on this one to convert it back. 2 times 6 is 12 plus 4. So we get 16 for our new top, and what's the original denominator? There we are. Okay, let's do it again over here. 2 times 5 is 10 plus 2. Original denominator, 5, right? Okay, let's go backwards on this one. Let's use a Dave. Remember, your bottom sticks out. So the 4 is on the outside, 7 goes inside the cave. And does 4 fit into 7? Yes, it does. Goes 1 time. 3 left over. So 1 whole time, 3 left over, original denominator, which is the 4. So a real life example of this, if you're going to make these delicious mouth-watering, ooey gooey, chocolatey, warm cookies, you should bring your teacher cookies more often, just saying. Anyways, if you're going to make these cookies for your teacher, and you have, let's say your recipe calls for 2 1/3 cup of brown sugar. Okay, but you can't fit the cup into this little jar. All you can fit is the 1/3 of a cup. Okay, so you're thinking, well, how many of these 1/3 of cups do I need to use if I'm going to do 2 1/3? And so you're questioning how many thirds. So let's do the loop and swirl. 2 times 3 is 6. Add the top is 7. Original denominator, thirds. So if you need 7 thirds, that means you're going to use this 1/3 of a cup to dip into the jar 7 times. And those 7 thirds will give you your 2 1/3 cup of brown sugar. And so let's draw this out a little bit here. Each cup, we'll say that's a cup, and that's a cup, and that's a cup. Just pretend these are all the same size because my drawings are so good. Okay, I'm dividing them up into thirds. Okay, and your recipe says you need a full cup and another full cup and then 1/3, right? So when we've got it drawn out, you can see that this is 3/3 and this is also 3/3 and this is 1/3. And because these fractions all have matching bottoms, that means we can add them up very nicely and see that we have 3 plus 3 plus 1 is 7 and original denominator. There's our 7 thirds. Now, go make the cookies. All right, one more little example. 2 1/4, loop and swirl. 2 times 4 is 8, plus 1 is 9, and that goes on the top, and original denominator was 4. And you can see in the picture that there were 2 whole, that's that guy, and 1 quarter. And so all they've done is taken the whole circles and drawn quarters on them as well to see that there are 1, 2, 3, 4, and 1, 2, 3, 4, and 1. So 4 quarters plus 4 quarters plus 1 more quarter is 9 quarters. Okay, 1 times 3 is 3, plus 2 is 5, goes on the top. Original denominator goes on the bottom. Okay, we're using a Dave. We're converting this improper, so improper, oh my gosh, back into a mixed number. So your bottom sticks out. So the 7 is the bottom, so 7 is going to stick out of the cave. How many times does 7 fit into 15? Well, it goes 2 whole times, and there's 1 left over. So 2 whole times is the big number, the leftover, and original denominator of 7. All right. Are the cookies ready yet? You can bring them anytime. I'm ready.